And if you wouldn't mind, oh, excellent, you're ahead of me. Colonel Diller, would you like to introduce Eileen and Gregory for their 8 minutes of speaking before we go to the actual workshops themselves?
Absolutely. And in the interest of time, we're going to accelerate through both of them and hand it directly over. Both experts in various ways with microelectronics. I'm going to hand it over to both of you right now for this quick discussion before we go to the design. Eileen?
Thanks. See it?
We can see your screen perfectly.
Excellent.
A little louder though, we can't hear you very well.
Oh, what about now?
Great, take it away.
Okay. Good morning, everyone. My name is Eileen Tanghal. I am a senior partner at InQtel. We are a technology scout and investor on behalf of the U.S. intelligence community. Although based in Arlington, Virginia, I am out of our West Coast Menlo Park office. Thanks so much for including me today. Myself and Lieutenant Colonel Greg Van Dyke are going to just give you some overview here. Our workshop parts are fairly open-ended. We don't have questions like the last speaker, but hope to have a robust discussion. So just to go through this, I think most people here know what microelectronics are. They really underpin most of the technology revolutions. In the defense sector, obviously, almost everything is running on a microelectronic, everything from your advanced navigation systems to your hypersonic missiles are all dependent upon microelectronics. If we look at the microelectronics cycle today, it is hugely global. You have the US and Europe really dominating in terms of designing semiconductors. The semiconductor capital equipment market is really mostly owned by the United States, with one exception, which is ASML in Holland. But in terms of where the actual microelectronics are produced, packaged, assembled, and tested, that is largely in Southeast Asia, which of course is presenting supply chain challenges to us. That's one of the topics for the workshop. The developing microelectronics itself is highly, highly complex. If we were to look at large semi companies, they can have up to 16,000 different suppliers. And that really creates a large attack surface for anyone that wants to disturb not just electronics that are going in for DoD, but people like Apple, large companies that are making their products depend on these microelectronics are also interested in ensuring that those circuits, those technologies are not being manipulated in a way that causes unplanned obsolescence or full out failure of their products. So there's three areas where things can be attacked: pre-silicon, where people can put in backdoors, they can have you put in IP that hasn't been vetted, in silicon, when you're actually making the circuits themselves. So you can manipulate the process or the equipment to cause failures, either from changing layouts or just process manufacturing failures in general. And then post-silicon, this is where a lot of the focus has been. This is maybe one of the riskiest areas. So in the packaging assembly line, people putting in counterfeit parts, test validation, sort of faking validation, that sort of thing. And this is a place, again, that many people have been focusing on now. An area that we'd like to talk about today. Now, so the first kind of part of the workshop is to talk about, indeed, supply chain and ensuring security. But the other thing we want to talk about during the workshop is really the innovation here. So I've been in semiconductors for about 25 years. I've been an investor in the semiconductor industry for about 19 years. And unfortunately, in the time frame that I've been doing this, I see, a weakened investment going into this sector. It is unlike some of the other areas that are new and hot amongst the venture capitalists, like the Agility Prime that was discussed, the Space Prime that sees a lot of venture capital investment. Because of the relatively long cycles and large capital needed here, you really see semiconductors being a small fraction of the overall venture capital deals taking place. So in 2019, it was about 0.5%. This is really a shame, because if we look then across the world to China, who really does understand that this is important, not from just a defense point of view, but from a great power economic point of view, we invested in half the number of deals that they invested in. So we're at about 85 versus 167. The other thing that I've seen as a venture capitalist is really, although you have the DoD and startup community kind of helping in the earlier stages, when they get to the later stages, a lot of companies, especially those that don't have the words AI in them, so if they're doing sensing, compute, comms, hardcore semiconductors, they really, really struggle to get the later stage investment. And something the DoD can do, of course, is ensure that there is a demand signal. This is much like what was talked about at the Agility Prime to attract more capital. But just some numbers here for you. If you look at the China deals, those deals get $30 million on average, whereas ours get 11.4. So I'm just going to now hand over to Lieutenant Colonel Greg Van Dyke to talk about some of the needs for semiconductors for the DoD. Greg?
Thank you, Eileen. Yeah, really working closely in collaboration with the commercial space is absolutely imperative to get the capabilities that we need for national security systems. So why do we need microelectronics? Why is it so important? Well, as we shift to great power competition with technologically equal and hopefully never more advanced adversaries or competitors, it's really the technology that's going to drive that military dominance on the battle space. And at the end of the day, I mean, I might be a little biased, but it's the guts that count now. It's F-35s, 24, probably more at this point, million lines of code that take all of the sensor data that platform can bring to bear, process it, and then give it to the pilot in a way that they can make decisions. And that is really the extreme advancement of that platform and why it makes it a world-class capability. However, there are a lot of programs across the DoD that have technologies that are at least 10, 20, and even more years old. And now, while I'm not saying that every program needs state-of-the-art capabilities, there is a wide swath of them that absolutely do as we compete against near-peer adversaries. Eileen mentioned a couple: hypersonics, 5G, AI, missile defense, autonomous systems, space systems. And really, if you want to think about it, boil it down to when we were back in squadron officer school or any professional military education, it's that OODA loop, that observe, orient, decide, act. And it's to be able to do that faster than the adversary. So taking in a lot of information from sensors and then somehow figuring out what that data means and then presenting it to either a user in the loop to make a decision or an autonomous system. And
hey,
so
Greg, about 30 more seconds, please.
Yes, sir. Microelectronics is absolutely the bedrock for every single national defense system going forward. Next slide. Oh, there we go. Okay, so just to go over quickly in 1 minute, these are the challenges of why it's so difficult to get these capabilities into our systems. We have very unique applications, whether it be sensor fusion, unique AI, advanced packaging. We have unique environments, rad, hard, temp, vibration, shock, etc. High reliability, they're highly critical systems, nuclear certification, long lifetimes that they're going to be out in the field, which could be multi-decadal, which is not similar to the commercial space. Security is a huge issue, not just at the fab, but from design all the way to get product out into the field. Long system development and production timelines, which really bring in technology freeze requirements. We have significant ITAR and EAR considerations that are right now preventing us from getting state-of-the-art capabilities we need to counter emerging threats. Low quantities, we are not a big player in this space. High input costs, shuttle runs can be in the millions, design tools can be in the millions per year. I'm not going to give you specific numbers because of that.
Greg, just a few more minutes on those numbers, or sorry, a few more seconds.
On those are specific to companies. Overseas production that Eileen talked about and limited manufacturers. There are currently only three state-of-the-art manufacturers in the world at advanced nodes. There's soon to be a fourth, which is SMIC or SMIC, which is a Chinese companies. So you better believe that our adversaries are going to have access to these advanced capabilities, and we absolutely need to do the same. So with that, Brandon, I'll turn it back over to you. Thank you very much. I look forward to a very engaged discussion this afternoon in the brainstorming session.
Thanks, Greg. Yeah, I can see hundreds of people starting to log into these Zoom meetings. So you need to head over to yours. Thanks for that overview. Nate, anything you want to say about teeing up these 6 simultaneous Design a Prime workshops before I do the logistics?